In terms of managing the coordination process, the contractor will have to play a leading role, in a sense that the contractor will need to obtain the different models from the design team as well as from his subcontractors, right? So once he has the different models from the different design trades and the different subcontractor trades, he will need to combine all these models together into what we call the coordination model. And the coordination model will allow, crash detection, for example. Okay, so once the crash is detected between the different trades, then the contractor's role is to assess whether is he in a position to resolve the crash. Okay, so if let's say he's able to resolve the crash with a minimum implication, he will go ahead to do it, and then after that rerun the model again to look at the aggregated this model view to see whether is the problem resolved to a satisfactory level. Alright. Now, if he's not able to resolve the crash, then he will need to set up a coordination meeting between the related parties. Okay, and if there is really a need, he will need to create the request for information, right? And then get the different parties to respond to this request for information. So you can easily imagine that if there is no coordination process between all the different stakeholders, the different designers, the different subcontractors, it will be very messy to ensure that communication is carried out in a very effective manner. In the traditional way of coordination, there is actually gathering of the affected stakeholders to discuss the issues, but the way it is done or the flow is not very systematic, or it's not very systematic. So that's why we make use of the coordinated BIM model to allow a more systematic transfer of information between all the different affected parties, so that the resolution or the answer can be found as soon as possible to resolve the issue. Which is to say that the contractor can make use of the coordinated BIM model to allow all the different stakeholders to concurrently means at the same time, be able to see the extent of the problem or the clash, and then as a result try to decide, or resolve the problem on the spot if it is possible. Okay, so you can have different trades or different services or different types of designers, that is designing the different aspect of the building or the facilities. And there is a very high chance of clashes between the different trades or the different types of design, which is natural because most of the time everybody works on their own, which we say that is working in their own silo, SILO, silo. Alright. So if you work in your own silo, you are not aware of what the other party is doing, then there's very high chance of possible clashes. So then you can have a coordination model, to check for the this clashing, and then after that it can churn out the statistics in relation to the types of clashes, and then that is where the coordination actually comes in. So if there is a need, then the party can raise this RFI, and then after that we can modify the this coordination model, as a result of revisions, by either trades, or more information that is put into the model, and then we update the model, and then after that do a pre-crash detection, and if the crash are detected, we get these different stakeholders to come together again to try to resolve the problem. So it's always in a continuous cycle, continuous cycle for improvement. But all this while we are all talking about the same BIM model. So that's why BIM model sometimes we say that is what you call the single source of truth, okay, or single source of truth. Why single? Because everybody is looking at the same thing. Why truth? Because this model is reflecting the actual information, okay, real time, live, okay. So if everybody is looking at the single source of truth, it's easier to be able to resolve the problem lah, okay. So that is the advantage of using this VDC program, okay, which uses this Beam as a backbone, okay, or uses Beam as a backbone. The building information modeling model or BIM model comes as a 3D model, okay, in the basic layer of information. However, the contractor can make use of VDC tools to upgrade that model into a 4D model. Alright, a 4D model. So the traditional way of project planning is done through creation of the construction schedule, which then conveys the sequence of various activities over a period of time. The construction schedule in the traditional way of doing things, they do not effectively communicate where in the project the activity is actually taking place and to what quantity, because it's not very easy to visualize from just 2D drawing and the basic information. So in that sense, a 4D model, okay, is actually a 3D model with the additional element of time, which is the fourth dimension. And what we are doing is that we link the different activities to the corresponding geometry. By geometry, we are referring to the length, the breadth, and the depth or the height of the various components. Okay, maybe the beam, the column, or the slab. Okay, the facade. Okay, this false ceiling. Okay, all these are geometry. Okay, to the information model. Then it will be possible to visualize the schedule within the building, and we can gain a better understanding of how the project, okay, should come together. Yeah. So this 4D model that shows you with respect to time, okay, which part or which component of the building should already be completed by a certain time, okay, it then can be compared against the actual site condition, okay. So you have three possible situations. The first one is okay, the actual site this condition, okay, is slower than what the 4D model is showing you. So when that happens, that means the project is going to suffer from a delay. Okay. The other possibility is that the actual site condition is much faster than what the 4D model is actually showing you. So that means the project is ahead of completion. Alright. And then the third situation is that it is showing you exactly what the 4D model is showing you. Okay, virtually. Alright. So then that means the pace is the same. Okay. Yeah. So that will allow, okay, the stakeholder, which is the contractor, okay, to have a better control, okay, over the execution of the construction, okay, of the project. So in a sense, we are incorporating the CPM, which stands for critical path method scheduling, together with the 3D model to give you the 4D model for BIM. And that will allow you to have more flexibility to add or to modify the work breakdown structures, the details. Okay, you can then have a different scenario where you look into the different resource allocation. You can look into your temporary works and site logistics planning. You can use it for your internal review, constructability review, or to validate the actual on-site progress. Okay, so you can continuously update your 4D model. Okay, so you review the 4D simulation with the project delivery team, including this H and this S practice. Okay, right? Or until the team is confident, okay, that the plan is optimized and is ready for this construction. Okay, or you can also make use of the 4D model to carry out risk analysis, carry out the safety analysis, or it's just a digital rehearsal, okay, of the pace of the progress of the work that is going to take place when the site is physically going to carry out the work, right? So the 4D model can also be used to optimize, okay, the program, okay, by allowing the stakeholders to carry out the what if scenario. Okay, you can do your dynamic crash detection, okay, yeah, or so you can also during the construction stage, okay, use it as a tool, okay, in terms of look ahead meeting, tracking the progress in the field, okay, allowing you to have a 4D view report compared to the actual progress, okay, or so and so forth. Right. You can also further upgrade the 4D model into a 5D model, or because the quantities can actually be captured from the 3D BIM model. So the 5D model can connect the quantity information to a cost estimation database. So using the 5D cost estimation model will reduce the calculation time needed to calculate the different quantities, increases the accuracy, okay, of the cost estimation. So changes to the model geometry or information will be able to be updated almost instantaneously, so that can subsequently allow for an update of the cost estimation. The contractor can also create and make use of a tracking model. So this tracking model is used to capture the site work and the construction progress. Yeah. So it is used to visualize the sequence of the construction. So your geometrical element like your beam, column, slab, okay, can be further subdivided to reflect certain elements, how they are actually installed. If let's say you have say a precast component, okay, how it can be installed, right? So that tracking model can also be used for on-field inspection purposes, used to track the completion ratio in order to drive the payment of these different trades downstream. So far, we have discussed the different type of design models and the construction models. We'll be looking at other forms of VDC models like the experience simulation model, as-built model, and the 3D model next. The experience simulation models allow any stakeholder to have a simulated experience, which can be created through the visualization of the BIM models. So the materials, the graphics, lighting, signage, and other information can be layered into the 3D BIM model. Okay. Non-project related objects such as people, plants, vehicles, and other things that would populate a building or facility can also be added to increase the richness of the 3D or the experiential BIM model. So the camera path are then defined, and the conditions like the time and the day or the weather can be simulated. When the project is completed and handed over to the end user would also want to have a model to help them in their day-to-day maintenance and operation. So we can actually then upgrade the 5D model to create what you call a 6D model. So the FM, facility maintenance, or the operation and maintenance software, okay, they are powerful database that can assist in managing the building facilities, right? Upon handover of a construction project, all the necessary documentation and information that are traditionally put into a binders or saved in a PDF file format, okay, for FM personnel, they can be inputted into the model. So the BIM model is a spatial database that can host and transfer critical data needed for operation and maintenance. And that will allow the end user to be able to run his facility or the building in a more effective manner, right? So that's the advantage of a 6D model.